Today's lesson is on solving exponential equations. Our focus for this part of the lesson is to solve exponential equations. First of all, what's an exponential equation? Now, an exponential equation is any equation with a power that has a variable in its exponent. So, for example, we have 5 to the power x. This is a variable. This is the exponent. So that's the variable. The power is on one, but also is equal to another base to an exponent. Now, this exponent on the other side is given, or it could be also include a variable. This is also could be another variable over here. So the power on one side of the equation, the other side of the equation could be a constant or another power with a variable in its exponent. For example, if we look at this one here, we have on both sides, we have variables. The bases are the same, therefore the exponents are the same. Let's look at another example and find. We have, so equation contains power with a variable in its exponent. So we have a power with a variable as the exponent. And one strategy solves this equation if having two powers with the same base are equal, their exponents are also equal. We can write that as b to the x equal b to the y. Therefore, x equals y. So there's the exponents here are equal if the bases are the same. The bases must be the same or else this will not work by itself. You will find as we go through into a few exam questions, you will be given bases that doesn't seem to be that are not the same, but you have to convert it so that the bases are the same. I will go through a few examples. So the bases are the same here. Here we have an example, 3 to the power x equal 81. So now what you'll do, you'll make 81 a power of 3. So 3 to the power of 4. So now we have the bases are the same, therefore the exponents are also equal. So we say x is equal to 4. Now before we go into some of the examples, and the first example we'll look at is example 1 here. But before we go into these examples, let's review our exponent rules. Just remember, for B we have A is not equal to 0 or B not equal to 0, the product rule. Now notice the bases, the A referred to the bases. These have to be the same for this condition. The condition is that the bases have to be the same for you to add the exponents. So here you have the product rule, a to the x times a to the y is equal to a to the x plus y. You have to remember these rules because to solve exponential equation, it requires that you change the form of the equation or the base in such a way that you're able to get a common base. Once you have a common base, you have to know how to add the exponents or multiply. In this case, we have a quotient rule. We have a division. We have a to the x divided by a to the y is x minus y. The power rule, we have a bracket, a to the x, bracket to the y. You multiply. Don't confuse it with the product rule. Right? And it makes sense. The product rules means you multiply. The quotient means you divide. The power rule means you have an exponent here. And here, power of a product rule. Here you're multiplying, but you have an exponent. So refers to a to the x b to the x. Power of fraction rule, similar. You have a over b to the power x, therefore a to the x equal over b to the x. This is critical. A to the 0 is 1. Then we have negative exponent. You'll find a lot of these. You'll be using many of these negative exponents concepts. Then we have fractional exponent. We have a to the x over y is the root y to the power x. Now, you'll find some good examples if you go to your chapter 5, exponential and log function example booklet. On page 13, page 13 is a review of the product rule, and there's some examples. Here we have the product rule. We have 2 to the power 3 times 2 to the 4 is 2. 3 plus 4. Don't multiply them. That requires, that will go to the when you need to multiply, you're looking at the power rule, which is this one here. So we have a power rule when we multiply the exponents. Now, when we go to the quotient rule, more or less, we'll subtract the exponents. We'll show you how to do that. The quotient rule, here we have the quotient rule, we subtract the exponents. We have 2 to the power of 5 divided by 2 to the power of 3 is 2 to the 5 minus 3. Power rule. Now this will be using many of these a lot because we have 4 to the power 2. It also aligns with these two here. So we have 4 to the power 6 because 3 times 2. And then we'll apply the quotient rule. In this case here, we change this into a power of 4 also. Negative exponents, this will be used extensively. A to the negative a is 1 over a, x to the a. For example, 3 to the negative 2 is 1 over 3 to the power 2. Now, this should be 1 over 9, not... Okay, there's a typo there. X to the power 0, which will give us equal 1. 5 to the power 0, and x to the power 1 is x. So just review and just make this correction. This should be 1 over 9, not 9. Okay. Let's go to the first example, and we'll be referring to the product rule frequently, or the quotient rule, or we'll be referring to these rules here. So when I say quotient rule, product rule, I'm referring to one of these. And I'll show you what I'm doing and what they are. So let's look at the first example. Here we have, remember a rule, the bases must be the same for us to add. If you go back to the first example here, the base is the same. Here, now if the base is not the same, we have to write it as a power. In this case here, we write a to 1 as a power of 3. So we get the base is 3. Now 3 to the power 4 will give us 81. So because 3 to the power 4 is equal to 81. So I replace 81 with 3 to the power 4. Now the bases are the same, the exponents are equal. If you look at our first question, 2 to the power x. Now, if you go to our rule here, we'll be utilizing this fact here, a to the negative x is 1 over a. So we know this part here is the reverse. But to do this, we'll do it in stages. Step 1, I'm going to write 128. To make it simpler, write 128 as a power of 2. So 128 is equal to, now we have 2. Now, if you use your calculator or your mental math, now if you don't want to use mental math, you can go to your calculator. And we have 2 to the power 7, 128. Or you can use prime, 2 times itself, how many times it gives us. There are other strategies you could use. Oops. Okay, so we know 2 to the power 7. I'll replace that 2 to the power x equal to 1 over 128. Now this becomes 2 to the power 7. So we have 2 to the power x, 1, 2 to the power 7. Now we will use our negative exponent rule. In our negative exponent rule, we have 1 over a to the x is referred to a to the negative x. So this is my x, so this is my a. It becomes 2 to the power x is equal to 2 to the negative 7. Now I'll equate. So in this case, I use my negative exponent rule. And just to remind you, 1 over a to the x is equal to a to the negative x. So that's what I'm using here. The next step is to equate the exponents. Because the bases are the same, therefore the exponents are equal. So x is equal to negative 7. Now you can do a test if you desire. You could write this original equation 2 to the power x is equal to 2 to the negative 7. So 2 to the negative 7 is equal to 2 to the negative 7. Which is 2 to 128 is equal to 1 over 128. So it's a test. Okay, test to make sure you're in the right path. Okay, let's look at the next question. We're going to go on to we'll just put a line across here, so we'll now notice we have basis 4 and the basis 8. If we are, and we cannot write 8 as a power of 4. In this case here, we wrote 128 as a power of 2. Here I need to find a power that both could be changed into or be used. So we have 8, so we said 8 cannot be written as a power 4, but of 2. So for example, we have 4 is equal to 2 to the power 2. 8 will be 2 to the power 3. So we have this here. We have is equal to 8x minus 1. I'll put a bracket around those. So replace 4 with 2 to the power 2. So we have 2 to the power 2. Put my bracket to keep it nice and compact. And replace 8 with 2 to the power 3. Now, here we're going to use our exponent or power rule. If you have a to the x or a to anything in the, to the power y, we multiply them. So we have here 2 to the 2x, we multiply these two. So I'm following here the product rule. So we have goes here, then we can use the product rule. So 2, which is a to the x times y is equal to axy. So this becomes 2x. Now this becomes 2 to the 3x minus 1. Two x is equal to 2. Now 3 times x minus 3. Next step, we equate exponents. We'll take the exponents here, we're going to equal, they're equal. Yeah, because the bases are the same. The bases are the same, therefore the exponents must be equal. 2x equal to 3x minus 3. So we have 2x minus 2x plus 3 is equal to 3x minus 2x minus 3 plus 3. So these guys are gone. It's gone. So we're left with 3 is equal to 3x minus bx. X is equal to 3. So we could have written, so our original equation, so this is my final answer, x equals 3. We can test our answers. We can go back and test it. Which we have. We have 4 to the x is equal to our original equation. Go back to our original equation. 4 to the x is equal to 8x minus 1. I'll rewrite it here, which is 8 into x minus 1, and x is equal to 3. So let's substitute 3 for x. So we have 4 over 3 is equal to 8, 3 minus 1. So 4 over 3 is 8 to the power 2. 4 to the power 3 gives us what? 4 times 4, 64. And 8 times 8 is 64. So it is true. Let's look at example 2. And in these examples, we'll be referring to the exponent rules. So I'm going to just put a line through here so it tells me to keep my now we know there's a basis 2, this is 4. So step 1, we want to make sure we have a common base here. So we'll write 4 as a power of 2. So we'll write 4 as a power of 2. So this becomes 2 to the power of 2. So we'll replace, this is my question, I'm going to highlight it. We have 2 to the power of x equals 4 root 2. Notice, by the way, this is actually 1. I'm going to just make it, this becomes 4. This 4, sorry, becomes 2 to the power of 2. 2 to the power of x. Notice I'm getting a common base here. And what do I have here? I'm going to just indicate this is square root, so that becomes 2 there, and this will become 1 out here. It makes your work easy to follow. I'm just break it into its different components. Now here we have fractional exponents, which is, if you go back here, we have fractional exponent, a x to the y. Now we have this here. We will change that into an exponent. So this becomes, now change this to exponent. So we use a fractional exponent. Remember a rule, square x to the, or y, look good, y ax is equal to a to the xy. Now that's why I wrote 1 here, because that becomes x. So we have 2x is equal to 2 to the power 2. Now this can be written as 2 to the 1/2. So I'm going to separate these here. So 2, 1 over 2. So using this ruler. Next step, now we have 2 to the x. We are going to apply the product rule now. The product rule now, if we have two bases that are the same and you're multiplying, the product rule says for you to add the exponent, which is, let's put the phone out there. Product will be a base is the same for this guy here. Since the base is the same, the exponent now, we are going to add the exponent. And that's why we're doing this part. Becomes 2 we're going to combine 2 plus a half. So these bases are the same. So I'm applying the product rule. Now we have that. We have a common base. Therefore, the exponents are equal. So if you want to write that, we have a to the x plus y is equal to a x plus y. Just to remind you, that's what we did here, the product rule. The next step, we equate the exponents because the bases are the same. Well, this look kind of not straight here. 2 to the power x. So now we equate the exponents. So x is equal to 2 plus half, which is 2.5, or 5/2. You can go ahead and substitute the value for x into our original equation, and you'll find it will be equal. Just to if you want to test it, let's go back. We can test this as our test. 2 to the power x is equal to 4. This is the original question. X is equal to 5/2. So we have 2. So this left side should be equal to 4/2 for it to be the same. Now, we are going to use our fractional, in this case here, we're going to use our fraction exponent rule, which is wonderful here. So we're going to convert it into a root. So this becomes 2 to the power 5. Now, this could be broken down. 2 to the power 5 is 2 to the power 4, 2. Okay. Now remember, this is the square root now of 2 to the power 4, which will be, if I broke them into 2 squared, be 4 times 4, root 2. So it becomes 4/2, which is equal to 4. This is 1 here, 4/2. So it is correct. Let's do a test. And you can verify your work by doing a test also. This other example involves the solid radicals. And in this case, what you would like to do, write both sides as a power of 3. Is this is a prime number is 3, so we cannot get lower than 3. So step 1, write both sides as a power of 3. So it means this is already a power of 3 here. So we have a change of 9 to a power of 3. So 9 is equal to 3 to the power 2. So I'll rewrite that as square root of 3 x minus 1 is equal to cube root of 3 to the power 2. Put s around that to make it look nice and compact. Now, I am going to use, for both of these, the fractional exponent rule. Okay, we have fractional exponent rule, so we can apply that here. Which is, we have the root y a to the x is equal to a x to the y. So I'm going to change this to 3 to the power 2 over 3. And this becomes 3. Remember, this is a 2 there. I'll change that into a half. So it becomes 3 to the 1/2 bracket x minus 1 is equal to 3. Now I can change it to 2 over 3. Now we have our exponent. Next, we will use our power rule to multiply these. So it becomes 3. That becomes half x minus 1. I like to keep brackets, so to keep my work much simpler, easier to follow, becomes 3 to 2/3. Now I have the bases are the same. Now the bases are the same, we can equate exponents, make exponents equal. Now it become half x, so half x, I'll rewrite it here, half x minus 1 is equal to 2/3. What we have here, we have half x minus a half is equal to 2/3. Now I need to get rid of my fractions. So I'm going to do one more step here so you can see in details. Now the lowest common denominator, 2 and 3, would be 6. So I multiply both sides by 6. So I'm getting rid of my fractions. Now 6 times a half gives me 3. So we 3x minus 6 times a half is 3 here. And on my right side, 3 can go into 6 2 times. 2 times 2 is 4. Now I simplify my calculations. Now I have 3x is equal to 4 plus 3. So 3x equals 7. X is equal to 7 over 3. And we can also prove that our answer is correct by substituting 7 over 3 for x in our original equation. You see the left side is equal to the right side. So let's recap. Step 1, we make sure we have a power that's equal on both sides. In this case, we change 9 to a power of 3. It becomes 3 to the power 2. Then we use the fraction exponent rule to change our root, cube root of 3 to the power 2 to 3 to an exponent. We also use our power rule to multiply 3 to the power x to the x minus 1. Once we have the bases the same, we equate the exponents and solve for x. I'll do a few more examples today. And this is found in your textbook. And since we've done a few examples on the power product rule, etc., this one here, we write 2/5 to the power of 2. Ready? So we write 250 as a power of 2. So a to the power of x is going to give us 2 to the power of 8. X is equal to 8. Pretty basic one. Here, I changed that to a power of 2. So this becomes 2 to the power of 2, x minus 1 is equal to x plus 3. Now, we're going to use our power rule. It's 2 to 2x minus 2. It's 2 times x is equal to x plus 3. Now, if we work it over here, we have equate our exponents. 2x minus 2 is equal to x plus 3. We'll have 2x minus x equals 3 plus 2. We have x is equal to 5. F, we have 9 to x plus 1. So a little bit here, higher. We want to equate these into using the exponents. So we write 9 an exponent of 3 because we'll find a common between these prime numbers. 3 can go into 2 4 to 3 5 times, like 3 times itself to the power. So first of all, we write, so 2 4 to 3 is equal to 3 to the power of 5. And 9 is equal to 3 to the power of 2. So I'll rewrite these. So it becomes 3 to the power of 2 equals 3 to the power of 5, x plus 3. Now we do our magic here. We have what? 2x, since the base is the same, 2x plus 2 is equal to 5x plus 15. This one, this or exponents, so I'm going to rewrite those up there. And we solve that, we end up with negative 3x is equal to 13. X is equal to negative 13 over 3. I'll look at a couple of examples in your textbook. Question 9c. And here, you're asked to find for for x. What you want to do, now here we have a base of 2. Let me just rewrite this a little bit. Looks like part of this is 2 here. So 2 to the cube root of 4. So we want to write 4 as a power of 2. So write 4 of a power of 2, so it becomes 2 to the power of x plus 1. I'll separate these two. Two to the power 2. I can write it like that to make it a bit more compact. So now I have 2x plus 1 is 2 to the power 1. I can write that there. This becomes 2 to the 2/3. We're going to use our product rule. We're going to add the exponent. So we have 2 to the x plus 1 is equal to 2 to the 1 plus 2/3. Take it up here. We have x plus 1. We can highlight our exponent. Equal 1 plus 2/3. And what we have here, we have that x is equal to, we went negative, so we have these going to be equal to 2/3. Because we take the 1 over there, become negative, and 2/3. We'll do one final from 9, and then we'll look at a couple of examples in 10 that are very tricky ones. So in this example, what you like to do, we have 216 and 36. Chances are of getting an exponent of 36 is very small. So we lose. The most likely one here is change 216 and 36 in a power of 6. So this gives me 6 to the power 2, x minus 1. Brackets are very useful in these questions because it makes it easy to follow your work. 216, we have 4. We change that to 6 to the power 3. Next, we use a fractional exponent rule. This becomes 6 to the 3 1/4. So basically, this will become 3 to the power 4. We can just shortcut it. Short by now, you know this. Becomes 6 to 3/4. This becomes 6 to the 2x minus 2. Now we equate, we have 3/4 2x minus 2. I'll take this up there. We have 2x minus 2. So we have 2x minus 2 is equal to 3/4. We have 2x is equal to 3/4 plus 2. So 2x is equal to 2 and 3/4. Or we can change that to a fraction, which is 2x is equal to, what, 11 over 4. So x is equal to 11 over 4 multiplied by 1 over 2. 3 dividing. So x is equal to, gives me what, 11 over 8. Okay, I'll go through a couple of tricky examples in the question 10. So you'll have a fair amount of these in your example booklet. So your next assignment, by the way, is from your, for you to submit to marks in your chapter 5 exponential log function booklet, is to complete lesson 3. So there are various examples here for you to complete. There's enough practice. And so there are 3 pages. Just would like for you to try some of these questions in your textbook. The answers are given. So we have A, B, C, D. But this one I'd like you to be careful about, which is D. Yeah, interesting one to look at, but just want to be careful with D. But let's look at E. It's a really interesting question because it has so many components to it. But if you look at E, what we want to do is to make this now 4, it can be written as exponent of 4. So we have to make this all exponent of 2. This becomes 2 to the power 3. Let's write it a bit more compact here. So this becomes 2 to the power 3, 1 minus x. And we'll change all of these here. We have cube root 2 to the power 4. Now I can put a 1 here to tell me, hey, look, I'm going to put that over there. And then this becomes 2 to the power 2. Now I have a series of, then we'll be using our fractional exponent rule here for this part here. Then we use a negative exponent rule. And also we have our power rule. So we're using all of those exponent rules. Let's change this immediately. First part here. So now it's 2 to the 4 to the 1/3. So 2 to the power 4. Now notice this is 1/3. You could also jump right away and say it's 4 over 3. That's fine. Now this is multiplied by 2 to the negative 2. I'm using the negative exponent rule here. And this becomes 2 to the power of 3 minus 3x. Because 3 times 1 is 3. 3 times negative x is negative 3x. Using your, in this case, our product rule, we're going to add the exponents now. I can change this immediately to the 4/3 times 2 to the negative 2. Let's write this a little bit base, a bit like the base itself. This becomes 2 into 3 minus 3x. So now I'm left with these here. We're going to subtract the exponent. We have 2 3 minus 3x is equal to 4/3 minus 2. And so now we have this equation here. We have now equate our exponents. We have 3 minus 3x is equal to 4 over 3 minus 2. We do all of this stuff, we get x is finally 11 over 9. So be careful with your work here. So try these questions in your textbook in question 10. You also would like to start work on your lesson 3 assignment. And the due dates are stated on the below. So let's recap. Our goal today is to solve exponential equation. And we said an exponential equation is an equation with a power that has a variable and is equal on one side, equal to the equation that could be a constant, in this case here, or it could be of another variable in this exponent. And we conclude from that if the bases are the same, then the exponents are equal. So our goal is to find the common bases, and therefore the equations solved for the exponent. We looked at using common bases one, and then we use ones that involve radicals. So there are two types, involving radicals and involving bases. And your assignment is to complete question 10. I've done 1E for you. And submit your lesson 3 assignment from your booklet.